Imagine looking up at the night sky and seeing one of the lights move. Not a satellite, not an airplane, a city on Mars. For most of human history, that idea belonged to science fiction. A red dot in the sky we could only dream about. Today, it is being engineered. NASA is building the rockets. SpaceX is testing the spacecraft. Engineers are designing the habitats. Scientists are mapping the ice. Lawyers are drafting the first frameworks for life on another world. The plan is staggering in scale. It is, in many ways, insane, and it is already underway. This is the plan to build a city, a real, functioning city, on a planet that no human has ever set foot on. The dream of settling Mars is not new, but the version we are living through right now is unlike anything in human history. For the first time, two of the most powerful space organizations on Earth are pushing in the same direction. NASA, through its Moon to Mars architecture, plans to use the Moon as a proving ground. Astronauts will return to lunar orbit and the lunar surface through the Artemis program, testing the suits, the habitats, the life support systems, and the long-duration know-how needed for a much longer journey. SpaceX, meanwhile, has stated something far more radical: a self-sustaining city on Mars. Eventually, in its founder's words, 1 million people. That number is almost certainly optimistic. Most space engineers will tell you it is, at best, a multi-generational goal. But the smaller, nearer steps, landing humans on Mars, building a base, expanding it into a permanent settlement, those are not science fiction anymore. They are line items, in real budgets, at real space agencies. And the reason any of this is possible at all has a name: Starship. Built by SpaceX, Starship is the largest and most powerful rocket ever flown. Stacked on its booster, it stands roughly 120 meters tall, taller than the Saturn V that carried Apollo astronauts to the Moon. It is designed to be fully reusable. Booster and ship, both meant to return, refly, and launch again, sometimes within days. If it works as intended, the cost of moving mass into space could fall further than any technology in the history of spaceflight. Starship has already begun proving itself. Recent test flights have demonstrated soft splashdowns, controlled re-entries, and, in a moment that genuinely looked unreal, the launch tower catching a returning booster in mid-air with its mechanical arms. The plan, in its current form, calls for Starships to launch in waves during the brief windows when Earth and Mars are favorably aligned, once every 26 months. The first ships would carry cargo, habitats, power, life support, equipment to make fuel. Only after those landed safely would humans follow. The very first crewed mission is unlikely to feel like a city. It will feel like a camp. A handful of astronauts, a pre-positioned habitat, solar arrays unfolding against red soil, a small fleet of rovers, and the constant background work of staying alive in a place that does not want you alive. Mars is, by every measure, brutal. The average surface temperature is around -63 degrees Celsius, -81 Fahrenheit. The atmosphere is thinner than Earth's by a factor of more than 100 and made almost entirely of carbon dioxide. There is no breathable air, no reliable liquid water at the surface, and no magnetic field shielding the ground from cosmic radiation. This is why the first base would not look like a city. It would look like a survival outpost. Pressurized modules, buried habitats, tight crew quotas, every gram of supplies carefully accounted for. But this is also where the real plan begins, because everything that follows, every future home, every greenhouse, every fueling station, depends on one idea: living off the land. The phrase scientists use is in situ resource utilization. In plain terms, using what Mars already has, instead of dragging everything across hundreds of millions of kilometers from Earth. And Mars, surprisingly, has a lot. Beneath the dust lies water ice, confirmed in vast quantities, especially in the mid to high latitudes. That ice can be mined, melted, filtered, and split into drinking water, into oxygen, into hydrogen for fuel. The thin atmosphere, dominated by carbon dioxide, can be processed too. NASA's Perseverance rover carried a small experiment called MOXIE, which produced breathable oxygen directly from Martian air. It worked. Quietly, on a planet 200 million kilometers away, a small machine made oxygen out of nothing but local atmosphere. Combine that captured CO2 with water-derived hydrogen, and you can synthesize methane, the same fuel Starship is designed to burn, which means, in theory, a returning ship could refuel using nothing but Mars itself. That is the keystone of the plan. A base that can refuel its own ships is a base that can grow, and this is the part most documentaries skip over. Because for all the renderings of glass domes and shining cities, the first decades on Mars will not be glamorous. They will be cramped. They will be exhausting. The early settlers will live underground or under thick layers of regolith, Martian soil, to shield themselves from radiation. They will breathe recycled air, drink recycled water, grow food in tightly controlled hydroponic chambers. They will spend their lives in spacesuits whenever they step outside. And many of the most important questions have not been answered yet. Can humans reproduce safely in 1/3 Earth's gravity? Nobody knows. Can the human heart, the spine, the eyes adapt to decades on Mars? We are only beginning to find out, with research from astronauts on the International Space Station. What happens, psychologically, to a small group of people living on a planet they can never realistically leave? This is not a dramatic flourish. These are real, open, scientific questions. The first Martians will be brave in ways we have not yet had to define. So, how does a camp become a city? Slowly. Then, possibly, very quickly. After the first base proves it can sustain itself, the cargo flights grow heavier. More habitats arrive, more greenhouses, power plants, likely nuclear, possibly supplemented by vast solar fields. 3D printers using regolith as raw material begin shaping walls, shelters, even roads. Each new launch window adds more people, more expertise, more redundancy. A doctor, an engineer, a geologist, a biologist, a teacher. If the math works, and that is still a very large if, within a few decades, the outpost could grow into a town. Within a century, perhaps something larger. A city, in the true sense, may take far longer than any of us alive today are likely to see in full. But its first foundation stones may be laid in our lifetime, possibly by people already born. There is a question that always comes back, no matter how many years we spend planning this. Why spend billions, eventually trillions, to live on a colder, deadlier, drier version of Earth? There is no single answer. For some, Mars is an insurance policy, a second home for a species that has only ever lived on one planet. For others, it is science, a frozen library of climate, geology, and possibly ancient life, a place that may once have been more Earth-like than anywhere else in the solar system. For others still, it is simply the next step, the next horizon, the next coastline. But there is a quieter reason that often goes unspoken. A civilization that builds the technology to live on Mars inevitably builds technologies that change life on Earth. Power systems, food systems, water recycling, closed-loop ecosystems, radiation-resistant materials. Mars, in this sense, is not just a destination. It is a mirror. There is a child being born somewhere on Earth this year who may grow up to walk on Mars. They will not know a world without it. They will look up at the sky and see, not a red dot, but a place, with weather reports, with time zones, with names for valleys and craters, a planet with neighborhoods. And though no one alive today knows for certain how it ends, whether the city is built, abandoned, or grown into something bigger than any of us can imagine, one thing is becoming very hard to deny. It has already started, not in some distant future, now, quietly, imperfectly, sometimes spectacularly, on a windswept launch pad in Texas, in a clean room in Houston, in a frozen plain on Mars where a tiny rover is still rolling across the dust, taking notes for the people who will follow it. The plan is insane, and it is happening.